Today we will divide polynomials with synthetic division. Synthetic division is a shorthand method of dividing polynomials by linear binomials, and you're just using the coefficients when you do this. So a couple things have to happen in order for you to use synthetic division. The polynomial itself must be in standard form. You're going to use 0 as a placeholder for any coefficient of a missing term, like if you're missing x squared or x. And the divisor must be in the form of x minus a. So we can't have 2x minus 1 or 3x or anything like that. It's x minus a. Let's look at some examples. So here we have x squared plus 6x plus 8 divided by x minus 2. So remember, we're looking for x minus a, and we have x minus 2. So a equals 2. This is in standard form. We have x squared plus 6x plus 8. So what we do here is we take our a value and we put it up here in a little box. Then you're going to take the coefficients of your polynomial. So we have 1, 6, and 8. Our next step is to bring the first number down. We don't do anything with it right now. Then we take this number and we multiply it by 2, and we get 2. 6 plus 2 is 8. Now we take 8, multiply it by 2, and we get 16. We add them together. 8 plus 16 is 24. And I'm going to put that in a little box here. Now that's great, but what do these numbers mean now? So the 24, whatever's in this last box here, is your remainder. So you're going to put your 24 over your divisor, just like we did with long division. It's positive, so that's being added to the rest of the equation, or expression here. Then we have 8. That's our constant. And then we have 1, which is our x. So that means it's now x, because 1x is just x, plus 8 plus 24 over x minus 2. That is our final answer. Now we have 3x cubed minus 2x plus 3. So the first thing I notice, this is in standard form, but we're missing an x squared. So that's a 0x squared. And then this is supposed to be x minus a, but I have x plus 2. In order to make it look like that, though, I could say this is actually x minus a negative 2. Because then minus and the negative would multiply together to make positive. So our a is negative 2. Alright, so we put our a in the box up here. We take all of our coefficients, 3, 0, negative 2, 3. And remember, we bring the first number down like this. We're going to multiply that by the number in the box, and that gives us negative 6. 0 minus 6 is negative 6. Negative 6 times negative 2 is 12. Negative 2 plus 12 is 10. 10 times negative 2 is negative 20. And 3 minus 20 is negative 17. So remember, this is our remainder. This is our constant. This is our x, and this is our x squared. So our remainder goes over our divisor, which is x plus 2. Then we have our constant. Then we have our x. And we have our x squared. So again, this is our final answer here. Alright, now you might see something that says, use synthetic substitution to evaluate the polynomial for the given value. And here's an example here. We have x cubed plus 2x squared plus 4. And then we're looking for x equals 2. So in this situation, the x would be your a value. So our a is 2. And we're going to do the same thing as synthetic division. We're just going to interpret that last number a little bit differently. It's not going to be the remainder anymore. It's going to be the solution. So let's look at what that looks like. So this is in standard form, but we are missing the x, so the 0 is going to be the x. We put our a value in the little box up there, and we have our coefficients of 1, 2, 0, and 4. Going to do the same thing. Bring 1 down, multiply it by the number in the box. 2 plus 2 is 4. 4 times 2 is 8. 0 plus 8 is 8. 8 times 2 is 16. So we get 20 in this box here. So what this is actually telling us is that P of 2 actually equals 20. So let's actually just solve this to see if we get the same answer, to see if that's actually true. So when we plug in 2, we get 2 cubed plus 2 times 2 squared plus 4. So that's 8, and then 2 times 4 is 8, and then plus 4. 16 plus 4 equals 20. So that's how you would use synthetic substitution. And if you want more practice on this, you can go to IXL, Algebra 2, L5, and 6. See you in Zoom.